Hey kiddos, it's me. I am back. I have not completely fallen off the face of the earth. Feeling much better, and I will actually be in class with you tomorrow. Speaking of class tomorrow, Mr. G did let me know that y'all did not have time to finish your test, and if you did, you felt a little rushed on Friday. So the first thing we'll do is I'll give you about 15 minutes so that you can go back over your answers, double check your work, and finish any problems you didn't have a chance to finish, and then we'll get to the lesson. And speaking of the lesson, here is your video for tomorrow. It's all about independent and dependent relationships, and so the first thing I need you to do is I need you to copy this chart down in your notes so that you understand how all of this flows together. The table just sort of brings it all together, the words that you're going to be hearing me say, and now so that you know how they relate to each other. Cause and effect is a concept that you're familiar with. It's a language arts concept, but it goes very well with independent and dependent relationships because the cause is the independent variable and the effect is the dependent one, because whatever the effect is, it depends on what the cause was to begin with. And then, of course, X is your independent variable, Y is your dependent variable, and goes through the table. So get the table copied down, and then you might have to pause for a second, and then we'll move on and talk about independent and dependent, which is a pretty simple concept, especially since you've been introduced to it in science. So the first thing we're going to do is we're going to take some situations and we're going to rewrite them showing dependency, and then we're going to identify what's independent and what's dependent. The first sentence we have says an employee who works longer hours will receive a larger amount on her paycheck. And so we're going to rewrite it in a phrase that is like this. It says the blank depends on blank. So we always have to identify the two variables. In this problem, the two variables that we're dealing with are the number of hours worked and the amount received on your paycheck. So the longer hours worked, you get more on your paycheck. So what I want you to think about is, if I were going to put it in a sentence, would I say the hours depend on the paycheck, or does the paycheck depend on the hours? Think about that for just a second before we fill it in. And what you want to be able to say is that the amount of your paycheck, for most people, depends on the number of hours worked. Now, if you don't get paid by the hour, this is not true. For instance, I don't get paid by the hour. So this is not true for me. But if you get paid by the hour, this is a true statement. The amount on your paycheck depends on how many hours you work. Now that we have put it that way, and we have put it in a showed dependency, we can identify what's dependent and what's independent. Right here it says the amount of the paycheck depends on. That makes the amount of paycheck your dependent variable, because it depends on something, and what it depends on is the independent variable, which is the number of hours worked. So let's look at another one. A box with several books weighs more than a box with just a few books. You have two things happening here. And it's hard to identify the variables here, but you have a box with several books weighing more than a box with just a few books. So you have the number of books is one thing, and the weight of the box is the other. So let's think about it into a dependent relationship. This has changed the words here. It now says is a function of. That is the same as depends on. These mean the same thing. If something is a function of something, then it depends on that something. So let's go back and think about it that way. Does the weight of the box depend on the number of books, or does the number of books depend on the weight of the box? Obviously, the weight of the box is a function of or depends on the number of books. And so the words is a function of, you're going to hear that a lot because algebra is the study of functions. You'll hear that a lot, but it's the same thing as depends on. So in this statement, our independent variable, you see how they have reversed it on you, is now the number of books, because that's the thing that something depends on. And the thing that depends on that is the weight of the box. So your dependent variable is the weight of the box. So whenever you're doing independent and dependent relationships, you always want to think about which one depends on the other. Which one do I have to know in order to find out the other thing? So let's do one more. The fire was very large, so many firefighters were there. So we have two variables. We have the size of the fire right here and the number of firefighters here. So does the size of the fire depend on the number of firefighters, or do the number of firefighters depend on the size of the fire? We're going to rewrite it. So I would say that the number of firefighters, and I'm just going to say firemen because it's easier to write, depends on or is a function of the size of the fire. I should slow down with my writing. It's been a while since I've used my air slate. So there it is in a dependent statement. This number of firemen depends on the size of the fire. So your dependent variable here is the number of firemen. As it says in our statement, they depend on, and what they depend on is the size of the fire. So that is your independent variable. Just some things to think about. So let's do a couple more. This one we're going to come back to at the very end. We're going to move on here. Let's practice just a little bit. You have a cause and effect chart, and I know that you made a chart earlier, but we're going to fill in this cause and effect chart based on the cause. We're going to find the effect. So here is a list of things that are causes. It's hard for you to see because that is now in the way. And here are, I apologize, I have suddenly decided to open about 3 more documents that do not need to be opened. Let me close these. Okay, so we're going to take, these are our effects over here, now that I've got everything shut back down. Here are the effects. We're going to take these effects and fill them in, and we're going to do just a few of them, and then we'll move on. Okay, so the weather. The weather is the cause, so it is the independent variable. What depends on the weather? So let's look at what we have here. Your height does not depend on the weather, so it can't be that. The amount of money you earn does not depend on the weather because you don't work in a weather-related job. The grade in your class does not depend on weather, but the type of clothes you wear certainly depends on the weather. Okay, so let's do this one down here. The number of minutes you walk. The number of minutes you walk is the independent variable. So something depends on the number of minutes you walk. So your grade in this class does not depend on how many minutes you walk. You can walk all day long and your grade in this class could not change. How much time it takes to download something, I don't think walking has anything to do with that. The number of calories you burn depends on the number of minutes you walk. So let's just do one more. The length of the song is the independent variable. What depends on the length of the song? So look at your things over here. The time to download would depend on the length of the song. The longer the song, the longer it will take to download, vice versa. So let's do a few more examples so that we can move forward. So the student council is planning to raise money by selling Halloween ghost pops. They are not taking orders in advance but hope to sell 2,000 ghost pops. The cost to order ghost pops from Patty Polly's Pops is 10 cents each, and the student council will sell them for 50 cents. So let's fill this in, okay? Vocabulary first. You have a equation right here, y equals 0.50x minus 200. Well, the 0.50x is the 50 cents per pop. The minus 200 we will discuss in just a minute, but a definition first. A mathematical function, which we're going to talk more about tomorrow, expresses a dependency relationship. One quantity depends in some way on another quantity. Mathematically, this above situation can be described by the function, and they give you this function. This is the mathematical function for the situation above. So using that description of the situation as well as the function, we're going to determine the independent and dependent variables. If you look at the situation, X we know is the number of ghost pops because they are 50 cents each. So I'm just going to say it's the number of pops. Y then is their profit because they're trying to make money. That's their goal. They're trying to make money and they have to pay 50 cents for each one, and that's their number, and X is their number of pops. So your two variables are profit and number of pops. So let's think about this for a minute. Does the profit depend on the number of pops sold, or does the number of pops sold depend on the profit? And if you go back to that table that I made you fill in at the very beginning, you will see your X and your Y are in that table, and you should be able to tell me right away which one's independent, which one's dependent based on that table. So if you go back to this table, you will see that X is the independent variable and Y is the dependent variable. So without having to go very much further, X is independent, Y is dependent. Now that we've decided what those two things are, the independent variable is going to be your X, so it's the number of pops that are sold. The dependent variable is the profit that they're going to make because that's your Y. That's what Y stands for. And so their profit depends on the number of pops sold. So here's, you're going to put it. So profit depends on the number of pops sold. And so the number of pops sold determines the profit. So you see this could be put either way. So the number of pops sold determines the profit. Now in that function that was written, the y equals 0.50x minus 200, we have this minus 200, but nowhere in the situation was there a 200. There's a 2,000, but there's not a 200. Where did that minus 200 come from? Think about the situation. Think about what it's saying, and what does that minus 200 represent? Where did it come from in order for them to write their function? Well, if you think about it, it says in the situation that they are planning to sell 2,000 pops. Well, 2,000 pops at 50 cents each is going to cost them, that's $1,000. Okay, so it doesn't have anything to do with that. The minus 200 is going to be their startup fee. It's their startup cost. It's what they had to pay before because it has to be deducted from their amount that's their profit. So it's being deducted from the amount they make. So it's their start cost. It's how much they have to pay for the pops. It's how much they're paying for advertising. It's their startup cost is what that amounts to. So let's do another one, maybe two more. We'll see what we can fit in. So I'm a heavy foot. Rammed her car into the garage door while she was texting. This is why you should never text and drive. The overhead door company charges $750 for a garage door plus $40 for each hour for installation. If X represents the number of hours, it tells us right here, this is the number of hours. And Y represents the total cost that I'm a heavy foot will have to pay. The equation describing the situation is this. Y equals 40x plus 750. Y is the total cost. X is the number of hours. 40 happens to be how much it is per hour, and the 750 is how much the garage door is going to cost. But we just want to know the independent and dependent variable. By the way, when you are asked this question, 40 is not a variable. Neither is 750. Those are called constants. They are numbers that will not change. You are looking at variables. What changes? X and Y. So you have your total cost and your number of hours. Like we looked at our table a minute ago, X is independent. So the number of hours is your independent variable. And your dependent variable is Y, so that would be your total cost. And so when you are looking at this, we write it as a function statement. You're going to say that the total cost, because that's your dependent, is a function of, because if you remember, that's the same thing as saying depends on the number of hours that they come and work. So it's the number of hours worked. And so if you want to say that, you know, in a different way, you could say that the number of hours worked affects the total cost. It helps you to see these written both ways because it could be presented to you either way at any point. So one more question. Here's what we got. Brook trout and brown bear are climbing Long's Peak in Colorado. They start the day at 2,130 feet and can climb a half mile per hour. The first question is, what's the independent variable in this situation? Well, first we got to figure out what the variables are, okay? We know that they can climb a half mile per hour. So the number of hours it takes them to climb is one variable. The other variable is the total it takes them to climb. So we have two variables. We have the total time that it takes them to climb, and we have the number of hours. Oh, my foot went to sleep. I'm sorry. The number of hours that they climb. They sound the same, but they are not. So the total time that it takes them to climb depends on how many hours they climb that day. Okay? Or whatever. So the independent variable in this situation is the number of hours that they climb. And if I were going to write an equation for this situation, that's what they're asking for, an equation to represent this situation. Well, they start out at 2,130 feet. They've already gone that far. And we're trying to find, this shouldn't be total time, this should be total height. Total elevation, whatever you want to get to. But 2,130 is the height that they are at now. And they're going to climb a half mile every hour. This will get them to their total height. Well, I don't have an X and a Y here, but I could replace them. I could say this was X and this was Y. And so I would say 2,130 plus 0.5X is equal to Y. So the total height that they climb depends on how many hours that they climb. So that's independent and dependent relationships. We will practice this after you guys finish your test tomorrow. I cannot wait to be back, and I will see you guys then.